Hi, welcome to our VB Developing channel. Hope everyone is well. Today we are here with Data Science Part 19. Today we will discuss about matplotlib library. So in this tutorial we will know about how to plot data in matplotlib. As you can see here we will discuss about all this 13 things. Alright, first of all we will know something about matplotlib library. Matplotlib makes scientific plotting very straightforward. Matplotlib is not the first attempt at making the plotting of graphs easy. What matplotlib brings is a modern solution to the balance between ease of use and power. Matplotlib is a module for Python, a programming language. In this chapter, we will provide a quick overview of what using matplotlib feels like. Minimalistic recipes are used to introduce the principles matplotlib is built upon. Alright, now we will go to VS Code to see the programming. Here, first of all, we import the matplotlib library. Before experimenting with matplotlib, you need to install it. We have already installed, that's why we imported. If you want to install it, so please watch the Data Science Part 6 video from 55 minutes 55 seconds. Alright, now we will see some example. Alright, first we will know about how to plotting one curve. The initial example of Hello World. For a plotting software is often about showing a simple curve. We will keep up with that tradition. It will also give you a rough idea about how matplotlib works. Let's get started with one of the most common and basic graph that any plotting software offers: curves. Let's execute it. Now you can see here we got one curve. The window shows the curve y equals x square with x in the 0 to 99 range. As you might have noticed, the window has several icons, some of which are as follows. Here you can see this is the save icon. This icon opens a dialog, allowing you to save the graph as a picture file. You can save it as a bitmap picture or a vector picture. This is the left button pan icon. This icon allows you to translate and scale the graphics. Click on it and then move the mouse over the graph. Clicking on the left button of the mouse will translate the graph according to the mouse movements. Clicking on the right button of the mouse will modify the scale of the graphics. This is the home icon. This icon will restore the graph to its initial state, cancelling any translation or scaling you might have applied before. As you can see here, Now we will use NumPy. NumPy is not required to use matplotlib. However, many matplotlib tricks, code samples, and examples use NumPy. A short introduction to NumPy usage will show you the reason. Let's plot another curve, sin x, with x in the 0, 2 into pi interval. The only difference with the preceding script is the part where we generate the point coordinates. Let's execute it. So now you can see the output. Now we will see another example. Again you can see the output. Now we will know about plotting multiple curves. One of the reasons we plot curves is to compare those curves. Are they matching? Where do they match? Where do they not match? Are they correlated? A graph can help to form a quick judgment for more thorough investigations. Let's show both sin x and cos x in the 0, 2 pi interval as follows. Let's execute once. So as you can see the output. Now we will see another example. This deferred rendering mechanism is central to matplotlib. You can declare what you render as and when it suits you. The graph will be rendered only when you call plt.show. To illustrate this, let's look at the following script, which renders a bell-shaped curve, and the slope of that curve for each of its points. Alright, let's see the plot. One of the function call, plt.plot, is done inside the plot_slope function, which does not have any influence on the rendering of the graph, as plt.plot simply declares what we want to render, but does not execute the rendering yet. This is very useful when writing scripts for complex graphics with a lot of curves. You can use all the features of a proper programming language: loop, function calls, and so on to compose a graph. Alright, now we will plotting curves from file data. As explained earlier, matplotlib only handles plotting. If you want to plot data stored in a file, you will have to use Python code to read the file and extract the data you need. Now we will show you the text file, when our data is stored. As you can see, the file as time series. So now you can see the data. Let's see the example. So as you can see the output. So now, the following equivalent one-liner to read a text file may bring a smile to those more familiar with Python. Let's see the example. Now we will execute once. As you can see, the same output as earlier. And one more thing, in our data loading code, note that there is no serious checking or error handling going on. In any case, one might remember that a good programmer is a lazy programmer. Indeed, since NumPy is so often used with matplotlib. Let's see the example. Now you can see the output. This is as short as the one-liner shown in the preceding section, yet easier to read, and it will handle many error cases that our pure Python code does not handle. Let's consider the following task. A file contains n columns of values, describing n1 curves. The first column contains the x coordinates, the second column contains the y coordinates of the first curve, the third column contains the y coordinates of the second curve, and so on. We want to display those n1 curves. We will do so by using the following code. Let's execute it. So as you can see here, the plot. Now we will know about how to plotting points. When displaying a curve, we implicitly assume that one point follows another. Our data is the time series. Of course, this does not always have to be the case. One point of the data can be independent from the other. A simple way to represent such kind of data is to simply show the points without linking them. So now you can see the plotting points. Let's see here, the function plt.scatter works exactly like plt.plot, taking the x and y coordinates of points as input parameters. However, each point is simply shown with one marker. Don't be fooled by the simplicity. Plt.scatter is a rich command. By playing with its many optional parameters, we can achieve many different effects. So now we will know about how to plotting bar charts. Bar charts are a common staple of plotting package, and even matplotlib has them. The dedicated function for bar charts is pyplot.bar. We will enable this function by executing the following script. Let's execute it. So now as you can see the bar charts, for each value in the list data, one vertical bar is shown. The pyplotbar function receives two arguments, the x-coordinate for each bar and the height of each bar. Here, we use the coordinates 0, 1, 2, and so on, for each bar, which is the purpose of range, len, data. Now we will discuss about the thickness of a bar. Through an optional parameter, pyplotbar provides a way to control the bar's thickness. Moreover, we can also obtain horizontal bars using the twin brother of pyplotbar, that is, pyplotbar h. By default, a bar will have a thickness of 0.8 units. Because we put a bar at each unit length, we have a gap of 0.2 between them. You can, of course, fiddle with this thickness parameter. For instance, by setting it to 1. So here we just set, width equals 1. Now you can see here, the bars have no gap between them. The matplotlib bar chart function pyplot.bar will not handle the positioning and thickness of the bars. The programmer is in charge. This flexibility allows you to create many variations on bar charts. Now we will know about horizontal bars. If you are more into horizontal bars, use the bar h function, which is the strict equivalent of bar, apart from giving horizontal rather than vertical bars. As you can see here, we got horizontal bar. Again we remove the h, then our result will be this. So again you can see the horizontal bars. Alright, now we will know about plotting multiple bar charts. When comparing several quantities and when changing one variable, we might want a bar chart where we have bars of one color for one quantity value. So we can plot multiple bar charts by playing with the thickness and the positions of the bars as follows. So here you can see the multiple bar charts. The data variable contains 3 series of 4 values. The preceding script will show 3 bar charts of 4 bars. The bars will have a thickness of 0.25 units. Each bar chart will be shifted 0.25 units from the previous one. Color has been added for clarity. This topic will be detailed in Chapter 2, Customizing the Color and Styles. Now we will see this example in another way. Here, we iterate over each row of data with a loop for I, row in enumerate. The iterator enumerate returns both the current row and its index. Generating the position of each bar for one bar chart is done with a list comprehension. This script will produce the same result as the previous script, but would not require any change if we add rows or columns of data. Now we will know about plotting stacked bar charts. Stacked bar charts are of course possible by using a special parameter from the pyplot bar function. Alright, now you can see the stacked bar charts. The optional bottom parameter of the pyplot bar function allows you to specify a starting value for a bar. Instead of running from 0 to a value, it will go from the bottom to value. The first call to pyplot.bar plots the blue bars. The second call to pyplot.bar plots the red bars, with the bottom of the red bars being at the top of the blue bars. Now we will use another example. Now you can see here, for the third bar chart, we have to compute the bottom values as a plus b, the coefficient-wise sum of a and b. Using NumPy helps to keep the code compact but readable. This code is, however, fairly repetitive and works for only 3 stacked bar charts. Now we will see another example to we can do better using the following code. Now see here, we store the data in an NumPy array, one row for one bar chart. We iterate over each row of data. For the ith row, the bottom parameter receives the sum of all the rows before the ith row. Writing the script this way, we can stack as many bar charts as we wish with minimal effort when changing the input data. Now we will know about plotting back-to-back bar charts. A simple but useful trick is to display 2 bar charts back-to-back at the same time. Think of an age pyramid of a population, showing the number of people within different age ranges. On the left side, we show the male population, while on the right we show the female population. Let's see the output. The bar chart for the female population, in red, is plotted as usual. However, the bar chart for the male population, in blue, has its bar extending to the left rather than the right. Indeed, the lengths of the bars for the blue bar chart are negative values. Rather than editing the input values, we use a list comprehension to negate values for the male population bar chart. Now we will know about plotting pie charts. To compare the relative importance of quantities, nothing like a good old pie chart, that is. Now you can see the pie chart. The pyplot.py function simply takes a list of values as the input. Note that the input data is a list, it could be a number pi array. You do not have to adjust the data so that it adds up to 1 or 100. You just have to give values to matplotlib and it will automatically compute the relative areas of the pie chart. As you can see here. Now we will know about plotting histograms. Histograms are graphical representations of a probability distribution. In fact, a histogram is just a specific kind of a bar chart. We could easily use matplotlib's bar chart function and do some statistics to generate histograms. However, histograms are so useful that matplotlib provides a function just for them. In this recipe, we are going to see how to use this histogram function. The histogram will change a bit each time we run the script as the data set is randomly generated. The pyplothist function takes a list of values as the input. The range of the values will be divided into equal-sized bins, 10 bins by default. The pyplothist function will generate a bar chart, 1 bar for 1 bin. The height of 1 bar is the number of values following in the corresponding bin. The number of bins is determined by the optional parameter bins. By setting the optional parameter norm to true, the bar height is normalized and the sum of all bar heights is equal to 1. Alright, now we will discuss about plotting box plots. Box plot allows you to compare distributions of values by conveniently showing the median, quartiles, maximum, and minimum of a set of values. A box plot will appear that represents the samples we drew from the random distribution. Since the code uses a randomly generated data set, the resulting figure will change slightly every time the script is run. Let's execute it. Now you can see the output. The data equals random for I in range 100, variable generates 100 values drawn from a normal distribution. For demonstration purposes, such values are typically read from a file or computed from other data. The plot.boxplot function takes a set of values and computes the mean, median and other statistical quantities on its own. The following points describe the preceding box plot. Number 1, the red bar is the median of the distribution. Number 2, the box includes 50% of the data from the lower quartile to the upper quartile. Thus, the box is centered on the median of the data. Number 3, the lower whisker extends to the lowest value within 1.5 IQR from the lower quartile. Number 4, the upper whisker extends to the highest value within 1.5 IQR from the upper quartile. Number 5, values further from the whiskers are shown with a cross marker. Now we will see another example. To show more than one box plot in a single graph, calling pyplot.boxplot once for each box plot is not going to work. It will simply draw the box plots over each other, making a messy, unreadable graph. However, we can draw several box plots with just one single call to pyplot.boxplot as follows. Let's execute it. The pyplot.boxplot function accepts a list of lists as the input, rendering a box plot for each sublist. And it will be generate randomly. As you can see here. Now we will know about how to plotting triangulations. Triangulations arise when dealing with spatial locations. Apart from showing distances between points and neighborhood relationships, triangulation plots can be a convenient way to represent maps. Matplotlib provides a fair amount of support for triangulations. So first here we import the matplotlib tri. Note one thing here, every time the script is run, you will see a different triangulation as the cloud of points that is triangulated is generated randomly. Now see here, we import the matplotlib tri module, which provides helper functions to compute triangulations from points. In this example, for demonstration purpose, we generate a random cloud of points using the following code. Now see here, we compute a triangulation and store it in the triangles variable with the help of the following code. The pyplot.triplot function simply takes triangles as inputs and displays the triangulation result. And each time when I executed, we got different triangulation. So friends, our today's video was up to this. Thanks for watching the video. See you in the next video. Please subscribe the channel and don't forget to like and share the video. Thank you.